Hello everybody, it's me again. I know you're missing my voice carrying through your ears, but here we go. We're going to try this a little bit more for our physics for potential energy and kinetic energy, and we're going to use a roller coaster to do that. And here is our formula sheet. We know all of these things, we've talked about them before, but now we're going to put them into roller coaster physics. What I need you to do right now is make up this table. Okay, I'm going to take a minute here to get that organized and get it set up. You can pause the video if you need to in order to get this all made up so it looks like this. All right, now here is our roller coaster. Ta-da! There it is. It's a beautiful one. It's a gorgeous one. So what we're going to do now is we're going to go back and forth between this sheet and your tables. Let's start at point A. Point A. So we're looking at our sheet here, and we're seeing point A. Point A is going to be 90 centimeters, but as we can see on our chart here, it says in meters, so that's going to be 0.90. All right, and based on that, we're going to try to figure out all of the other parts that are in that particular column. Well, the first thing we know is that at point A, nothing is moving. So the amount of kinetic energy is 0. And we know that the velocity has to also be 0 because it's not moving. So we need to figure out its potential energy and its mechanical energy. So we have to figure out a couple of things here that we need to know. Number one, we are going to discount friction. So therefore it's a frictionless track, okay? And that we're not including any kind of air resistance. So there's no resistance as this roller coaster travels through this particular course. So we need a couple of other things. So let's take number one. What's going to be the mass of our car? We're going to have the mass be 500 kilograms. So the mass of our vehicle is 500 kilograms. Our height we've already got, and we already know what gravity is. So we can quickly jump into mgh, which is the mass 500 times kilograms times 9.81 meters per second squared times the height, which is 0.9 meters. We multiply that all out, and we get 4,414.5 joules. 4,414.5 joules. So what's our total mechanical energy? Well, if we go back to our chart, we know that mechanical energy is potential energy plus kinetic energy. So we know that this has to be the sum of this plus this has to equal this. Well, it's this plus 0, so therefore it equals that. So total is 4,414.5 joules of energy. And we've now completed part A of our roller coaster. Part B is a little bit more interesting because it's way down here at the bottom. Well, if we know that that's at the bottom, how much potential energy is there? There is 0. Potential energy, 0. We know the height is also 0. So we now have to figure out, is there kinetic energy? Well, if there's no potential energy, then all of that energy must be in the form of kinetic energy. So let's put that there. And of course, the total mechanical energy has to stay the same. So now we need to figure out what the velocity of it is. Velocity. Okay, so we go back here, we look at our sheet, and kinetic energy is 1/2 the mass times the velocity squared. So we can use that formula to figure out what's going to happen. So let's see here. Velocity here going to go there. So we're going to find that it's 4,414.5 equals 1/2 500 times v squared. Divide that all out so that we get v squared, 17.658 meters squared seconds squared equals velocity squared. So therefore our answer is 4.20 meters per second. So at this point here, we have no velocity, and at here it's going 4.20 meters per second. Well, that's pretty good. That's a first drop, pretty significant, pretty good velocity for that short of a distance. Okay, so let's take a look here at point C. Point C is 0.40 meters high. So you can see it's a little bit high. It's not as high as A. It's less than A, but it's still significantly higher than there. So now we got to figure out what the new potential energy is. Well, the new potential energy is going to be mgh. So here we go. M was 500 kilograms times 9.81 meters per second squared times now our new height, which is 0.40. We multiply that out and we get 1962. Okay, so now we know that ME equals PE plus KE. Well, we know that ME is 44.145 joules. We know that PE is 1962 joules. So now we got to find out what KE is. Oh, wait a minute. We're just going to subtract that from that, and we get 2452. 2452.5. 2452.5 joules. So that is equal. So now we just do a nice simple job. We do KE equals 2452.5 joules equals 1/2 500 kilograms velocity squared. Nice and simple. Now we just go through the steps and we'll get 4905 equals 1/2. Oh no, take out the half now. 500 kilograms velocity squared. Divide both sides by 500 kilograms. V squared equals 9.81. So therefore V equals 3.13 meters per second. Okay, that's going to be meters squared seconds squared. Okay, and this of course is joules. So if we want to see that, let's do that out here. Let's go 4905 joules, which is Newton meters, divided by 500 kilograms. Well, Newton meters are kilograms per second squared. So kilograms and kilograms are going to cancel out. So that's how we get meters squared seconds squared. So when we take the square root that, we get meters per second. All right, so now we know that the potential energy in this particular one is 1962. We know the kinetic energy is 2452.5. We know the velocity is 3.13. And we know the total is 4414.5. So we just did all of the parts for point C. All right, so now we're going to take point D here, which looks like it's almost the same height, but that would be too confusing. So we're just going to make it 15 centimeters is the height of D. So this one's 15, this one's 40, and this one's 90. Okay, this one's going to be 0, and that one's going to be 0. So we can put E in there as 0 right now too, but that's okay. All right, so let's take a look here at our new potential energy. Well, our new energy is going to be 500 times 9.81 times our new height, 0.15. And that's going to give us 735.75 joules as our potential energy. So right here, we're going to write 735.75 for our potential. We know our total is 4414.5. So if we take 44.14.5 and subtract 735.75, we're going to get 3678.25. 0.75, my bad. 36875. 75, that's right. Okay, so there is our kinetic energy. So let's write that over here. 3678.75. And now we just need to find the velocity. Oh, wait a minute. So we know that this is 3678.75 equals 1/2 500 v squared. Now we just do our math out. We get 14.715 equals v squared. I'll let you do the rest of that math out. We just did it on the last one, so you can go back and take a look there and see what you need. And our answer is 3.84 meters per second is v. So we put here 3.84. Wow, that's interesting. How does the velocity go up when the height is lower? Well, remember, we're talking about the height at this point and the velocity at this point, and it hasn't gone up very high. So whatever energy it had here, it's not losing as much of it as it gets to the top there. So although it looks weird, it's kind of going to come up pretty interesting. Okay? So that gives us point D. So we've now done from here. Our car has gone down here, it's gone up here, it's gone down here, it's gone here. And now what we want to do is find out, well, what's happening at the end? Well, we know that the height is 0, and we know that it's at the bottom here, so the potential is 0. So the kinetic is 4414.5. This is 44.14.5. So, oh, wait a minute. This looks exactly the same as B. So there would be 4.20. Oh, wait a minute. Didn't we have a frictionless course? We did. So therefore, there was no energy lost to friction. So therefore, the vehicle traveled the same distance and traveled at the same velocity when it reached the bottom. The same as if it had gone from this point to this point without all these other stops in between. So there we have it. Roller coaster physics. I will send you a problem for you to do that will be just like this so that you can practice doing this. Thank you very much. Stay healthy, stay happy, and we'll talk to you again in the near future. Bye-bye.